So now we're going to move on towards the graphing part of the chapter. Now this first part's kind of graphing, kind of not. It's just going to be looking at features of graphs. So we're going to look at symmetry. So there's three types of symmetry that we'll talk about in this course. The first one is x-axis symmetry, and then y-axis symmetry, and then origin symmetry. So let's talk about x-axis symmetry first. So x-axis symmetry is anything where there's a point above the x-axis that's also there below the x-axis, right? So they'd be symmetrical. So let's say that this point is at 2, 3. You'd have a point down here at 2, -3. So it's equidistance from the x-axis at that same x point. So if you have a point 2, +3, you'll get a point 2, -3. So to test if something has x-axis symmetry, you can replace y with -y. And if it produces an equivalent equation, then we can say that the graph is symmetric with respect to the x-axis. So let's look at what that would look like. So this first one, you can see visually that this has x-axis symmetry, right? You've got a point up here at 2, 2. You've got a point here at 2, -2, right? 2, 2. So you get a point down here at 2, -2. Okay, so visually I can see it. From a point I can see it. But now I want to test algebraically. So what you do is you take your equation, y squared equals x minus 1, and you replace y with -y. So in for y, I'm going to put in -y. And then you simplify. So -y squared is +y. Now what do you notice happened? This equation and this equation match. So since it came out equivalent, then there is x-axis symmetry. Okay, let's move on to the next type of symmetry. The next type of symmetry is y-axis symmetry. So if you have a point here, let's say this is at -3, 12, then you're going to have another point equidistant from the y-axis on the other side. So if you have a point at -3, 12, you would also have a point at 3, 12, right? So you'll notice the y value stays the same, just like here the x value stays the same, but what switches is the x value. So you go from a -3, 12 to a +3, 12. So to test for y-axis symmetry, you replace x with -x. If it produces an equivalent equation, we can say that it is symmetric with respect to the y-axis. So this one I can visually see. Oh, it came in flipped. That's funny. So I was just starting with 4 and 6 are backwards. It doesn't matter. Okay, so we can see visually that this has y-axis symmetry. You can see like equidistance from each side. So let's pick a nice point. Let's say there's a point here. So this is a point at -2, 5. So if you have a point here at -2, 5, we also have a point here at 2, 5. So visually we can see that it's symmetrical. With a point we can see it's symmetrical, but now let's test algebraically. So the equation is y equals x squared plus 2, and you're going to replace x with -x. So in for x, I'm going to put -x, and then I'm going to simplify. Again, you'll notice that there's a lot of squaring. Squaring is what makes something stay the same. And you'll notice in this one the y was squared, and in this one the x is squared. And so look at that, we get our equivalent equation. This is the same as this, therefore there is y-axis symmetry. Okay, last one. The last one is origin symmetry. So origin symmetry is that if there's a point down here, let's say at -3, -2, then there would be another point that is equidistant from the x-axis and equidistant on the y-axis. In other words, the point -3, 2 would also appear as +3, 2. Okay, so if something's down here, it goes over here. If something's up here, it ends up down here. Right? So it's equidistance in the x's and the y's. It's almost like you're reflecting it across the y. We haven't talked about reflections yet, right? It would go over the y and then over the x, or over the x and then over the y. Okay, so to test it, you do both. You replace x with -x and y with -y. if you produce an equivalent equation, it's symmetric without the origin. So let's look at a question like this. So let's test a point first. We've got a point here at -2, -1. I'm expecting to have a point at +2, +1. Oh, look, there it is. Visually, I can see that the graph is down here in the third quadrant, and it's also up here in the first quadrant, so I'm guessing this is origin symmetry. But I take the equation y equals 1 over x, and I replace x with -x, and I replace y with -y at the same time. Oop, that was supposed to be a y. So I'm going to replace the y with -y. I'm going to replace the x with -x. Now this one didn't have squares in it, and that's okay, right? But what happens is I get -y equals -1 over x. Well, that's not technically the same as this yet. So what I want to do is change it. So let's divide or multiply. Let's multiply both sides by -1 because that just looks easier. So if I multiply both sides, I'm allowed to do something to one side as long as I do it to the other. So I'm going to multiply both sides by -1. I end up with y equals +1 over x. Now this equation is equivalent to my original equation, and so it has origin symmetry. But you'll notice that these ones don't have the others. Like this one doesn't have y-axis symmetry and x-axis symmetry. Like if I replaced y with -y, it wouldn't work. So only these three tests are going to work with these three equations. All right, so go and test for some symmetry in your notes.